Greetings to every one of you. So in this video we are going to discuss another very important concept from data structures and algorithm, that is counting sort. This algorithm, it is different from all other types of sorting algorithms. It is a non-comparison based algorithm. If you take all the previous algorithms, we used to compare value of one element with the other element, but in this case it is not, and it is very easy to code, and it is a stable algorithm. Let us see the algorithm first, then after that we'll go to the example. There is a given array with n number of elements. We have to find out the maximum value of the given array. Let us consider this a array given in which you have to find out the maximum value. So if you go through and we can find out this is the maximum value, that is 5. That is what is called range. The 5 is nothing but the range. So based on that 5 we have to create another array named the count array. So the size of that array must be k plus 1. Initialize that count array with all zeros. So you have to initialize this array with all zeros. For I is equal to 1 to n, find the count of every unique element available in the array. We have to find out how many number of times one particular element that is present in this list. See, for example, if you take 2, how many number of times 2 occurred in this list, in this array? So 1, 2, 3, 4 times. So that value should be entered here. Okay, that value should be entered here. There is nothing but the frequency of the element. How many number of times that particular element present in the given array. That is nothing but the frequency that we have to find out, and should be stored in the exact position. Next thing, we have to find out the cumulative sum. So what actually I have done is, we find out only the frequency, and based on that we have to find out the cumulative sum. And finally, from the input array we have to generate the output array with the help of the cumulative sum. Okay, so that is what actually given here. Restore the element, decrement or decrease the count of every restored element by 1. So if it is 15 and you have to reduce the value by 14. So you have to store the element in the 14th location. Let us see the example. So this is the given array with n numbers. So n is equal to 16, and the value of the k, that is the range, is equal to 5. How we got the value 5? 5 is the maximum value, the maximum element. So that is nothing but the range. So we have to create this count array with size k plus 1. That means the value of k is equal to 5. So you have to create an array with 6 location. So start from 0 to 5. As I said, we have to initialize all these value, that is 0. That is what actually I said. Then we have to find out the frequency. That is the third step. What is the frequency? We have to find out the frequency just by comparing each and every element, and if you see that element, that particular index should be incremented. That is the idea. You start from here, so count the value, that is 2. So we have to go to 2 and put the value, that is 1. 4, go to 4, it is 1. 1, go to 1, put 1. 5, go to 5, it is 1. 0, it is 1. Similarly 1, put the value, that is increment the value. So similarly, just you have to find out how many number of times one particular value is occurred in the list. See, for example, that is 2. If you take 2, 1, 2, 3, 4, the value 2 is 4 times that is occurred. Similarly, 4, count the value, that is 1, 2, 3. 4 occurred 3 times. Similarly, 0 occurred only 1 time, and 5 also occurred, that is only 1 time. Okay, what about 3? 1, 1, 2, 3, 4. 3 also occurred 4 times. So now just you count it and verify the total number of elements, that is 3, 7, 11, 14, 15. We got 1, 2, 3 times. Sorry. So you should get 16. Okay. So that is 4, 8, 12, and this is 16. Total number of elements present, it is 16. Now we have to find out the cumulative sum. How to calculate the cumulative sum? You write down this value, that is first, number 1 as it is. Add this value with this. 1 plus 3, so that is 4. 4 plus 4, that is 8. 8 plus 4, that is 12. 12 plus 3, it is 15. 15 plus 1 is 16. So total number of elements we have, what is that? 16 numbers. Okay. So using this particular, that is cumulative sum, we can get our result. Let us see how. So for that we have to go to the last one. So we have to start it from the last element. So that is actually we have to start it from n to, that is, what is that? 1. Okay. That is the last element. So you can say that it is 0, n to 0. Right. So see the value, that is 3. Come to this table. Okay. What is, where is 3? In 3 we got the element, that is 12. So what you have to do? Decrement the value. Now restore the value in the location 11. So 3 must be stored in location 11. Okay. So this is the first value. Now go to the second one. Second is also 3. So come to 3. Here decrement the value, that is 10. Store the value 3 in location 10. What is the next value? That is 2. Come to 2. What is the value? The element is 8. So reduce this value by 1, that is 7. In 7th location, store the value, that is 2. Next is 1. Go to 1. The value is 4. Reduce by 1, that is 3. In the location 3, store the value, that is 1. Next is again 3. Come to 3. What is the value? That is the location is 10. So reduce by 1. So store 3 in location 9. Now the next value is 4. Come to the index 4. So it is 15. Reduce it by 1. So it is 14. In 14 store the value, that is 4. Then it is number 3. Go to index 3 and reduce this value. It is 8. Store number 3 in the location, that is 8. What is the next value? That is 2. Come to the index 2. It is 7 already. Reduce the value, that is 6. In location 6, store the value 2. What is the next value? That is 4. Come to 4. It is 14. So reduce the value, that is 13. Store the value 4 in 13. What is the next value? That is 2. Come to 2. It is already 6. Reduce the value, that is 5. Store the value, that is 2 in 5. Next value, it is 1. Come to 1. Already it is the 3. Reduce the value, that is 2. In the location 2, store the value, that is 1. Next value, that is 0. 0. Come to 0. Reduce the value, that is 1. by 1, it is 0. Store the value 0 in the location 0. Okay, similarly the next one is 5. Come to 5, it is 16. So reduce it by 1. So in the location 15, store the value, that is 5. Next value, it is 1. Okay, next value, it is 1. Okay, come to 1. Reduce the value, that is 2 by 1, that is 1. In the location 1, store the value, that is 1. What is the next value? It is 4. Come to 4, location 4. Reduce the value, 13 by 1, that is 12. In the location 12, store the value, that is 4. Sorry, it is 4. Okay. Then the next value, that is 2. 2. Come to location 2. Here it is 5, 4. So in the location 4, we will store the value, that is 2. So now we can see that the entire the list, the numbers get sorted. Okay. And as for time complexity is concerned, so we are performing it for n numbers, that is it is order of n, and again the range of the value we are using, that is k. So in general we can the time complexity can be written as it is order of n plus k. Okay, so where n represent this number of elements and this k represent its particular the range, okay, the maximum value. Okay, so that indicates you will get the time complexity, it is order of n plus k. Okay, so in this video we discussed about the counting sort. I gave the introduction, then I explained this algorithm, and also with the help of this example, and also I discussed about this time complexity. I hope you understood this algorithm. Keep watching. Bye.